Okay students, let us try to do this particular question. It says the electrons are emitted with zero velocity from a metal surface when it is exposed to radiation of wavelength 6800 angstrometers, and you need to calculate the threshold frequency which we represent as nu naught. Okay, and work function is W naught. Fine. So now let us consider a metal frame or metal surface. You can consider, just for understanding, this is your metal surface on which radiation is falling, and this radiation of wavelength 6800 angstrom is falling. Now when this radiation are falling, when it strikes to metal surface, we have studied in photoelectric effect that electrons are emitted. Here it is saying that when this electron which is ejected out from the surface of the metal is having velocity equal to 0. Okay, so this is an important point, that the electron which is ejected is having the 0 velocity. Okay, with this much information, let us proceed further. Let us do the solution for this. And we know that energy of radiation which is falling, energy of radiation which is falling will be equal to work function, which we represented as W naught, plus we have kinetic energy of ejected electron. Okay, so this we are knowing that the energy of the radiation which is falling on the surface will be equal to the work function plus kinetic energy of the ejected electron. Now this energy of radiation we can write it as E, and work function we have W naught plus kinetic energy. Okay, now this E we can write it as h nu, where h is the Planck's constant, nu is frequency, and W is the work function, which can be obtained by multiplying threshold frequency with Planck's constant, plus kinetic energy you have half mv square. Now here we know that the ejected electron was having frequency velocity as 0. So if we put the value here for v as 0, then this particular whole term will be 0. That's why we don't take mass of an electron, just m is written, because you multiply that mass with 0, ultimately the answer would be 0 itself. So this whole term half mv square would be 0. So you are left over with h nu is equal to h nu naught plus 0. Here this Planck's constant also can be cancelled out, so you are having nu is equal to nu naught. Now what is this nu naught? Here is your threshold frequency. Now this threshold frequency is nothing but equal to your frequency, and the formula which you are known for the frequency is equal to c by lambda, where c has the value speed of light 3 into 10 to the power of 8 meter per second, and lambda is given to you in the question, that is 6800 angstrom. So here lambda is given to you in angstroms, and you can see that your velocity is in meters. So let us try to convert this into meters. So you can write that as minus 10 meters. Lambda will be 6800 into 10 to the power of minus 10 meters, is because you have 1 angstrom means 10 to the power of minus 10 meters. Fine. So we will put that value of lambda over here. You will have 6800 into 10 to the power of minus 10 meters. So you divide 3 by 6800, you will get 0.000441 into 10 to the power of 8. The denominator has 10 to the power of minus 10, which if it goes in the numerator will be 10 to the power of 10. So we will add 10 to 8. So, and also let us shift the decimal point. Also let us shift this decimal point between 4 and 4. So how many digits do we move? If you will see, we move 1, 2, 3 and 4 digits. So we can write this as 4.41 into 10 to the power of minus 4 into, you now have this 10 to the power of 8 plus 10, that is 18. Okay, so finally you will have 4.41 into 10 to the power of 40. And now what is the unit? You can see that meter will be getting cancelled off, so you are left over with per second as the unit for your frequency or threshold frequency, which was the first requirement of the question. They were asking you to calculate the threshold frequency, which we have calculated. Now next they are asking you to find out the work function, which is W0. So now let us try to solve for work function. So now your work function, which we represent as WO, is nothing but H-0. Work function, when you are multiplying threshold frequency with Planck's constant, you get back work function. So now let us try to put the values. Planck's constant has value 6.626 into 10 to the power of minus 34 joule second, and nu0 you have just now found out, 4.41 into 10 to the power of 14 per second. If you multiply 6.626 with 4.41, you get 29.22 into 10 to the power of minus 34. We add the powers of 10, so you have minus 34 plus 14. So you are having 29.22 into 10 to the power of 34 minus 14 will be 20. 34 is a greater number having minus sign, so we put a minus sign over here. Now this decimal point can be shifted towards left by 1 digit. So I can write this in scientific notation form like this: 2.9 into 10 to the power of 1, because I have shifted by 1 digit, into 10 to the power of minus 20. So finally the answer is 2.922 into 10 to the power of minus 19. And the unit would be, you can see that this seconds per second will be getting cancelled off, and you are having the unit of work function as joules. So WO is your work function. So now you can see that the whole question is solved in two parts. First, calculating threshold frequency, that we have done here, knowing that frequency is equal to threshold frequency because velocity was given to you as 0. That was first part, and the second part was work function. Hope you have understood the numerical. Thank you.